Today's class, we are going to learn about IoT communication protocols. First, we need to know what is a protocol. So protocol is a set of rules and regulations in order to perform a particular task or do a job. Okay. Suppose with respect to this IoT only, in order to have a communication between, it can be a wired or wireless communication using an internet. In order to have that particular communication, we need to follow some set of protocols and their rules. Okay, so what are all those protocols? What are their rules and regulations? How they behave? Okay, so how the data is transferred, everything we are going to see in this particular IoT communication protocol. So IoT communication protocols form the backbone of IoT system, and not only that, it enables network connectivity, coupling to many applications. So mostly the communication protocols in the IoT allow devices to exchange data over the network. So it can be basically an internet. So there are several protocols like link layer, network layer, transport layer, application layer. Okay, these are the most famously used protocols or the layer models. Okay, for the IoT communication. These protocols generally they are maintained for the data exchange format, data encoding, addressing schemes, okay, and for routing of packets from source to destination. Routing means sending the data in the form of package from source to destination, okay. So, and not only that, the other functions of a protocol also include sequence control, data sequence control, flow control of the data, and if at all any data has been lost, okay, retransmission of lost packets also be done with the help of these kind of IoT protocols. See, if you see the overall diagram of an IoT protocols, so each layer will be containing, okay, several services. Okay, so in the screen we have application layer, transport layer, network layer, as well as link layer. So application layer provides services like HTTP, COAP, WebSockets, MQTT, XMPP, DDS, AMQP. Okay, so I will be explaining you each and everything and along with its observation and the job it does. Okay, coming to the transport layer, it has the most famous services TCP as well as UDP services. Okay, so all these are generally protocols only. So coming to the network layer, most of the people will be, whoever is using the internet are well known with this particular network layer protocols, IPv4, IPv6 and 6 LO WPAN protocol, okay, and services. And coming to the link layer services, we have like wired and wireless, like 802.3 Ethernet, 802.16 WiMAX, 802.11 Wi-Fi, 802.15.4 LRWPAN, and also 2G, 3G LTE cellular services. Okay, so all these things we are going to see one by one. So let's see first application layer. So application layer protocols generally defines how the application interface with the lower layer protocols to send the data over the network. So application layer in the sense, we can generally call it as apps or the websites, okay, or the browsers, okay. So whatever we see with our eyes graphically, those can be considered as the application layer in order to user can easily operate them or use them for the data transfer. So this particular protocol is very much used to send the data over the network, okay. So mostly in application layers, port numbers are used for application addressing. So whatever the data you are sending using an application, okay, so based on the port, each and every data transmission will be having through a machine will be having a port number. Through that port number only we are able to send and receive the data. Okay, so application layer protocols enable process to process connection using the ports. So two machines are there, let us say. Okay, one machine is transmitting the signal with some data and another machine is receiving. Similarly, this particular machine, again, the second machine is again retransmitting some sort of message, and the first machine is receiving it. So what's happening? There are some ports enabled between these two machines such that through the port numbers they are able to exchange their data. Okay, it's a kind of chat, or it can be an audio, or it can be a video call. It can be anything. Okay, like a Zoom meeting or anything. Okay. Now, in the application layer, we have several protocols or the services. Let's see one by one. Quick overview. HTTP. First comes the HTTP. HTTP is nothing but the hypertext transfer protocol. Okay, it is one of the famous application layer protocol, which is the foundation of World Wide Web. www. If you go to a Google Chrome browsing or any kind of browsing, generally we see with World Wide Web, www, with some website names, right? Okay. And in the above link, you can also observe http:/:. You are going to observe, you will be observing all those things, right? So it's a protocol in order to send or transmit or receive the data through a World Wide Web foundation. Okay. So generally what this protocol do means it's a request response, okay, where client sends a request to the server using the HTTP commands. So HTTP includes most of the commands like get, put, post, delete, head, trace, options, etc. Okay. So this is not comments, it is commands. COMMANDS, HTTP commands. Okay, please ignore it. Now coming to the next service, we have COAP, Constrained Application Protocol. It is also a part of application layer protocol. So this is for the machine-to-machine applications. So in order to have a data transfer over the network between two machines. Okay, so this particular protocol is majorly used. Next comes the WebSockets. So WebSocket protocol allows full duplex communication over a single socket. Using a single socket only, a full duplex communication, transmission and reception of the signal can be done at a time, okay, over a single socket connection, and the communication, sending the messages between the client and server can be done simultaneously. And next comes the MQTT, Message Queue Telemetry Transport Protocol. So it is a very lightweight messaging protocol based on the publish, subscribe model. Okay. So this MQTT also uses a client server architecture where client connects to the server and publishes the messages, okay, based on the topics on the server. Okay. So it's a kind of publish subscribe model. Okay. So whatever the data we are sending using this MQTT protocol, that will be published, those messages will be published on this particular server based on the topics. Okay. Now XMPP. Okay. So this XMPP is nothing but Extensible Messaging and Presence Protocol. XMPP, it's a protocol for real-time communication. Okay. High performance applications like messaging, gaming, chat rooms, voice and video calls, those kind of things, these extensible messaging and presence protocols are very much used. They should be having a communication in real time. Okay, so there should not be any kind of delay with respect to this particular data conversation. Okay. Next comes DDS, Data Distribution Service. Okay, so it is a data-centric middleware standard for device-to-device or machine-to-machine communication. So between the device-to-device or a machine-to-machine, the communication need to be very much data-centric. Okay, so it also provides the quality of service control as well as configurable reliability. Okay. And coming to the AMQP, okay, this service is a protocol with respect to advanced message queuing protocol. So it is somewhat like a protocol applied for the business messaging. So AMQP supports both point-to-point publishers as well as subscriber model, like with the help of routing as well as queuing. Okay, so routing and queuing of the data can be done, and whatever they search for a particular topic, the message will be displayed, okay, in the server based on this particular requirement, and that too, this is specially for a business kind of messaging. Okay, this protocol is used. Next comes the transport layer. Okay, so the transport layer protocol is nothing but the end-to-end message transfer capability independent of the underlying network. Okay, irrespective of the uh, network. Okay, so it provides end-to-end message transfer. Okay, so this will be having majorly two. One is transmission control protocol. Another one is UDP, user datagram protocol. Okay, so transmission control protocol is most widely used the transport layer protocol. So majorly used for the web browsers like HTTP, okay, and for email applications with the help of a protocol called SMTP, and for the file transfer protocols FTP, okay. And coming to the UDP, user datagram protocol, it is majorly considered as a connectionless protocol, okay. So it is majorly used for the time sensitive applications and have very small data units to exchange. Okay, so the data also will be small and also useful for the time sensitive applications. Okay, and there's no much complex regarding the connection setup. Okay, it's a kind of connectionless protocol. Okay, it will be time sensitive as well as very small data of units will be available to exchange, or exchange of very small data units will be happening regularly. Okay, now coming to the network and internet or internet layer, these things. So the network layers or the internet layers are responsible for the IP, sending IP datagrams. So each and every process what's happening in the internet or the network layers will be with the help of an IP address, right? Okay, so once we are transmitting a data through source to the destination using these networks, IP datagram plays a major role. Okay, so this layer performs host addressing as well as packet routing. Okay, not only IP datagrams, along with that it also performs addressing the host. Okay, and we can also route the data packets wherever it want to go. Okay, so this particular datagram contains source and destination addresses which are used to route them from source to destination across multiple networks. So each and every data from where to where it is going. Okay, each and every, so source data will be also there and destination address will also will be there. With the help of this particular source and destination address, the data can be easily transferred even though there are multiple network connections. Now among these we have IPv4, IPv6 and 6 LoWPAN. Okay, so coming to IPv4, it's a most famous version. It's in the internet. So Internet Protocol version 4, it is the most deployed internet protocol which is used to identify the devices on a network. Okay, so it is mostly based on the hierarchical based, okay, with respect to the addressing schemes. Okay, mostly all the internet facilities nowadays are using the Internet Protocol IPv4 versions to identify a particular network or to use an internet. When coming to the IPv6, it's an successor of IPv4. Okay, it is the newest version of the Internet Protocol. Okay, than compared to the IPv4. Okay, it will be having some advanced versions as well. Okay, and coming to the 6 LoWPAN. Okay, it's a kind of IPv6 over low power wireless personal area networks. Okay, so it will be having an IP protocol, okay, especially designed for the IoT devices like low power devices which have limited processing capabilities. So suppose a device will be having a frequency range of 2.4 gigahertz and it will be providing a data transfer rate between 250 kb per second. Okay, it's a very small device which will be having a small range of frequency, which is connected over the internet and used for IoT applications. This is one of the protocol is used for the low power devices with less frequency and less data transfer. And coming to the next layer, link layer. Okay, so the link layer protocols determines how the data is physically sent over the networks or physical layer or the medium. Suppose we need to send a data. So it sometimes it can be an internet cable, sometimes it can be a wireless Wi-Fi router. Okay, so it determines how the data is physically sent, means it may be through a copper wire, coaxial wire, or a wireless radio waves. Okay, so link layer determines how the packets are coded, signaled by the hardware device over medium which the host is attached. Okay, how the data is transferred through a particular cable. So if at all we are using a cable to transmit the data, if at all we are using a wireless medium to transmit the data, we need to follow some rules and regulations like protocols. Okay, so coming to this protocols, we have a protocol called a standard called 802.3 Ethernet protocol. Okay, so this particular IEEE 802.3 is a collection of wired Ethernet standards. So generally we plug an Ethernet cable for the PCs or for the internets, right? In IoT devices also, we may use for this particular Ethernet devices with an IEEE 802.3 standards. Okay, so but these standards provide data rates from 10 MB per second to the 40 GB per second, and also sometimes higher. Okay, so Ethernet also will provide, though it's a wired connection, Ethernet will also provide a high data transfer. Coming to the Wi-Fi router, okay, so it follows 802.11 protocol, IEEE 802.11. It's a general wireless local area network. Best example is our router. Okay, so these provide a data rate from 1 MB per second to 6.75 GB per second, and sometimes higher also. So these Wi-Fi routers or the Wi-Fi devices which follows 802.11 protocol varies design to design or the standards to standards or the frequency. Okay, so we have 5 gigahertz and we have 2.4 gigahertz. Okay, all these routers are very much standards. According to that, the data transfer also differs. Okay, and coming to the 802.16 WiMAX protocol standard, okay, it's a collection of wireless broadband standards which is also called as WiMAX. Okay, so whenever several wireless broadbands are brought together and connected together to perform a particular application, IoT applications, then we need to follow a protocol called 802.16 WiMAX. Okay, so WiMAX standards provide data rate from 1.5 MB per second to 1 GB per second. And the last one is like 802.15.4 LRWPAN. So it's an protocol. It is used. It is an low rate wireless personal area network. Okay, so generally a wireless communication module is used for IoT device like Zigbee's. Okay, it's a modules, LoRa, Zigbee, RF, and all those things. Okay, so for that 802.15.4 LRWPAN, which is a low rate wireless personal area networks, these protocols are used. Okay, and these standards form the basic specifications for the communication protocol, like as I have already said, like modules like Zigbee's and all those things. And the data rate is also very, very less. Okay, so the data rate varies from 40 KB per second to 250 KB per second. Okay, this is what all the link layer, network or internet layer, transport layer, okay, and application layer, okay, varies. Okay, and in the link layer we also have a cellular protocol which will be having a second generation, third generation LTE or cellular kind of layer through which we can use data. Okay, so the mobile phones or the smartphones where we are using data, right, 2G, 3G, 4G, okay, that also falls under the link layer using a SIM card, okay, like a subscriber identity module. In that only a data service also integrated with the help of mobile cell sites. Okay, so all these layers, application layer, transport layer, network layer, link layer, all these layers are helps in developing the IoT devices for monitoring as well as controlling the IoT devices for various interoperability. As the definition indicates, interoperability is a characteristics of a product or a system whose interfaces are completely understood to work with other products or system present or future in their implementation or access without any restrictions. So let us assume there are two machines. So it can be some electronic or electrical products connected to the internet, or it can be a systems. Okay. So it can be currently in real time or for the future purpose. In order to have an access between these two systems, or in order to have an exchange of data, or in order to work for a particular application with respect to these two systems, we need to have a proper communication between these systems or machines. Okay. So interoperability is nothing but an operational ability between these two products, machines, or systems, okay, such that they will be communicating meaningfully and they can also exchange the data or the services. Okay. So first we need to know why interoperability is important in the context of IoT. Okay. So there are so many IoT objectives. So in order to fulfill these IoT objectives, interoperability is very much considered. Okay. So let's see what are the objectives. Physical objectives or physical objects can interact with any other physical objects and they can share their information. So these objects can be systems, machines, okay, or some sort of products connected to the internet. Okay, these physical objects which are integrated with the sensors, okay, or a sensor mechanism. Okay, so the major aim is to, or the objective is to share their information with one another. Okay, so any device can communicate with other devices anytime from anywhere. Obviously, if it is connected to an internet, these devices can communicate with the another devices anytime from anywhere. Okay, now machine to machine communication, device to device communication, device to machine communication falls under these IoT's objectives. Okay, so we also need to have a seamless device integration with IoT network. So using a simple internet connection, so we need to have an complex device integrations as well. So in order to satisfy a particular application. So in order to fulfill all these objectives, interoperability is one of the important contexts considered in the IoT. See, why interoperability is required? Generally because of the heterogeneity. Okay. So heterogeneity is nothing but there are several types of IoT machines or devices. Okay. Each will be working on their own according to the different applications. Okay. And each device will be having its own language, how to communicate, or the protocols, and it differs product to the product or the device to the device. Okay. So whenever all these machines or devices are brought together and we expect that to work for a particular application, there will be a lot of problems occurring. So interoperability is very much required in order to have a proper communication between all these different types of devices to perform a particular task in order to satisfy the application needs. Okay, so heterogeneity is also considered. So here we get several types of wireless communications where protocols are considered like Zigbee, Bluetooth, GPRS, 6LoWPAN, and Wi-Fi, and all these protocols are considered. If at all you take the wired communication, Ethernet, higher LAN layer, LAN protocols, all these are considered. If at all we consider the programming languages with respect to the softwares we use for the IoT or the devices or the hardware system we use. Okay, it can be considered as the embedded C, okay, JavaScript, C, C++, Visual Basic, PHP, Python, all each and every different types of IoT systems will be having their own programming languages in order to satisfy the requirement or the design. Okay, and we can also IoTs come across different hardware platforms such as Crossbow, and several many things are there, Node MCU, and so many are there, etc., etc. So interoperability is very much required in order to have or satisfy this heterogeneity. Now, let's see what are the different types of interoperability. So we have mainly two types of interoperability. One is user interoperability. Second one is device interoperability. Okay. So coming to the user interoperability. So interoperability problem between a user and a device. So we are going to satisfy or rectify the problem between the user as well as device. Whenever a person tries to use a particular device, an IoT device, or to communicate with an IoT device, so this particular user interoperability is very much considered. Okay, coming to the device interoperability, here the problem arises between two different devices. Whenever there are two different devices want to communicate with each other in order to satisfy an IoT application, there will be several problem arises. So in order to satisfy those problems, so we will be using this particular device interoperability. Okay. Now let's see what is a user interoperability as well as device interoperability one by one. See. Coming to the user interoperability, so the following problems need to be solved. One is device identification and categorizing for the discovery. Once you start using the hardware with respect to the IoT, so these particular devices need to be identified and also categorized, okay, in order to have a safe communication or exchange of data. Okay. The second one is syntactic interoperability for the device interaction. And the third one is semantic interoperability for the device interaction. What is syntactic and what is semantic? We are going to see now. Okay. See. So before getting into these particular three variations with respect to user or the device interoperability, let's see a basic example. Okay. So a person or a user from America want to access a CCTV cameras. One is located in the India, like Delhi or some part of India, and another camera is located in some Tokyo or Japan. Okay. So in real time, a person sitting in or user sitting in an America can access two different security cameras from two different countries of the world. Okay. So that too in real time. So interoperability should be very much maintained. So user need to have a proper communication between the camera present in the India as well as camera present in the Tokyo. And not only that, the two cameras need to have an communication if needed, if the application is required, okay, or if the application demands, okay. So there should be a proper communication between the cameras as well as there should be a proper communication between the user as well as the camera. Here the cameras are considered as the devices and the person who is monitoring or altering that particular or controlling the cameras, okay, can be considered as the user, okay. So now let's see how this interoperability with respect to device as well as user works. See, first thing is coming to the user interoperability. So we have device identification and categorization for discovery. Okay. So in order to identify a proper device like a camera which is present in a particular country or a location, we need to have some unique addresses. So these addresses can be provided with respect to electronic product code EPC, universal product code UPC, uniform resource identifier URI, and the most popular one is the IP addresses we have. With respect to IoT, mostly we will be using IPv6. Okay. So these provide unique codes or the addresses in order to identify a particular device or categorize a particular device which is applied for the IoT applications. Now, coming to the syntactic interoperability for device interaction, let's see what are these covers. Okay. So in the syntactic interoperability, the interoperability between devices and device user in terms of message formats. So whoever the user who is using a particular device using an IoT, so in terms of message formats, there should be some sort of communication. Okay. So the message format from a device to a user should be understandable, okay, for the user computer. The user, whoever using that particular interface or the software, Okay, so the device message for format, let me take an example of same user as well as camera. Okay, whatever the data sent from the camera should be understandable by the software or the user interface used by the user. Okay, now on the other hand, this message, whatever the person who is controlling that particular camera, whatever the message he sent, that also format also should be executable by the device. Okay, suppose let me turn the camera to a particular position. Okay, so based on the controls given by the user, so the camera will need to be turned. It does that particular operation only when it understands the message format, right? So syntactic, it's a kind of syntax. So both formats, the camera device format or the user for computer format, both should need to be understandable by the each other. Then only this particular syntactic interoperability for the device interaction is very much completed. Okay, now if you see the semantic interoperability for the device interaction, here what does it do is interoperability between the device and device user in terms of message meaning. Okay, not only as we have seen in the syntactic, the message formats need to be understandable, but coming to the semantic, not only the message formats, the message meaning also should be understandable by both the device as well as the user who is operating or monitoring that particular device. Okay, so the device can understand the meaning of user's instruction. So the device need to understand the user instruction, whatever the instruction has been given by the user, whether to zoom in, zoom out with respect to camera, or whether to capture a screenshot or record a video, or in order to rotate the camera, anything. Okay, so the meaning of the message format also should be understandable by the device, as we have taken the example of a camera. Okay, not only that, similarly, the user can also need to understand the meaning of device response sent from the device. If at all the camera is moving, okay, let us say, okay, in real time, we should also need to receive the responses with respect to a meaningful responses. So not only the message formats with respect to syntactic interoperability and also semantic, the meaning also should be with respect to the message also should be conveyed properly. Okay, coming to the next one, device interoperability. Okay, here we are communicating between device to the device. Okay, so user and device is most commonly done, but the communication between device and device should be very much taken care. Suppose two devices are there. Two devices are made in two different countries. Let us say each device will be having different types of sensors, different types of actuators, different types of controllers. The programming language may differ, or the overall configuration may be differing. Okay, so whenever you want to communicate with two different things, okay, a middleware bridge is very much required. So in order to have a proper communication between two different devices, okay, a bridge is a must. So here universal middleware bridge, UMB in short we call it as, that has been involved, okay, such that each and every device can communicate with each other properly. It can be in the message format or it can be in the meaningful format as well. If you see the diagram over here, we have power lines, Ethernet, we have camera surveillance, and we have everything, right? So all these things, each and everything is having its own programming language or the protocol, and all these things are connected to this particular UMB, Universal Middleware Bridge. This middleware bridge acts as a translator, or it creates several options for both the devices such that they can have proper exchange of data. So it solves interoperability problems caused by the heterogeneity of several kinds with respect to home network middleware. Okay, not only that, the universal middleware bridge creates virtual maps along the physical devices, and it also creates the compatibility among the middleware home networks. Okay, so on the whole, what we want to say is it helps or acts as a bridge between two different devices which are made of different protocols, hardware or software interfaces, but both can translate or exchange their data to have or fulfill a particular IoT application. That comes under device interoperability.